going to look at inverse functions. First thing we need to know is what is an inverse function? Quick little answer. Inverse simply means to undo, so an inverse function is something that undoes what the original function does. If your original function adds 3, then you're going to subtract 3 for the inverse. That kind of thing. If you remember back to Algebra 1 or before, we talked about function machines. A function is like a machine. When you put something into it, it gives you something out with a consistent pattern. So if I have a juice machine, if I put grapes in, I get grape juice. If I put apples in, I get apple juice. That kind of thing. Well, what would the inverse do? Inverse would look something like this. If we have grape juice, we put it into the grape machine, or fruit machine perhaps, and we would get grapes. If we had apple juice, we would put it in and we would get apples. What's the relationship that you notice about the domain and range of these two functions, or of a function and its inverse? If you notice, the domain that you started with your original function is actually going to be your output from the inverse. The range from the function is actually your inverse domain, what you put in. So really the relationship that you should notice about the domain and range is that they trade places. The domain of the original function becomes the range of the inverse. The range of the original function becomes the domain. So simply, they swap places. Alright, so what's going to happen if we have a composition, or if we compose a function with its inverse? That's going to look like you see on the screen, some function inverse put into the original function. Something like this. If I have, by the way, when we use that -1 power, that's actually not a power if you see an x or an input after your function. That stands for inverse. But if I put that as my domain or my input to my original function, as long as this function is, and the inverse is inside of it, it's going to undo whatever you do. So if I take a function that adds 3 and then I subtract 3, I'm going to be right back where I start. So whatever is here is going to be your output. Right? And that's going to work the other way as well. If we compose an inverse with its original function, the functions actually cancel each other out. So whatever you put in is going to be what you get out. That'll look the same even if I have numbers. If I do f inverse of 3, well, I'm going to get 3, because it doesn't matter what I did to 3, because I'm going to turn around and undo it. Right? That's the first thing. And again, it doesn't matter which function is feeding into the other, as long as it's a function and its inverse. It could be any function I want, as long as it's its inverse that it makes a composition with. And it can be any number. If I had 732, then I'm going to get 732 out. Whatever I put in, I'm going to get that same thing out. Right? So next, we're going to look at an actual example here, and we're going to be given the following function, just a set of points. It's not a consistent function, it's just these points, and we're going to state the domain and the range, then we're going to graph them, and it's going to look like this. Our domain, of course, is all the x values, or the inputs. So domain is simply going to be the set of numbers, -3, -1, 2, and 4. And the range is going to be the set of numbers, 2, -4, 6, and +4. It would be nice if we put those in numerical order. They're kind of kind of there, but not quite. Negative 4, 2, 4, and 6 would actually be the numerical order. But that gives me my domain and range. Next thing they ask us to do is graph. I am simply plotting points here. So I'll do negative 3, positive 2, negative 1, negative 4, 2, 6, and 4, 4. Alright, those are not connected. That's just a set of ordered points. It's a scatter plot. So the next thing they ask me, though, is to state the domain of the inverse function. Remember, domain and range swap from an original function to its inverse. So my domain is actually going to be that set from the range, the negative 4, 2, 4, and 6. The range is going to be the domain from the original. So negative 3, negative 1, 2, and 4. They want us to now graph the inverse. And if I do that, let's do that in a different color so that we can actually see what's going on. When I do that, and again, I changed the order up a little bit, so I'm not plotting the first two numbers together. I'm going to go to the top ordered pair, and I'm going to flip them. So that'll be 2, negative 3 that I graph. And that will be negative 4, negative 1 that I'll graph. And that will be 6, 2. And 4, 4 is actually going to put you back on the exact same spot. So take a look at that and see how those points changed up. Because we had, if we name these A, B, C, and D, see, that would be A, B, C, and D, whereas this would be A inverse, would be 2, negative 3, negative 4, negative 1, would be B inverse, C inverse here, and then D. Take a look, see what you think is happening. How do we find the inverse? Well, we know if we have a set of points, it's just that easy, what we did. Hopefully, you can think about, though, if I give you a function, you could come up with a way to find its inverse. Literally, the domain and the range switch places. Domain represents the x, range represents the y or f of x. Those two pieces in your equation simply change places. That's going to look something like this, stepwise. First thing you want to do is you want to make sure that you solve for y. Then you physically switch the x and y values, the domain and range, trading places. So you'll rewrite the equation with the x in the y's place and the y in the x places. You're going to solve again for the new y, and you're going to make sure that the domain and range of the function and inverse function match up. Alright, so you got to make sure that there's a way to check the inverse and the original domain. We'll talk about that a little later on. So our last example that we're going to look at is right here. Knowing those 4 steps, you want to make sure it's solved for y first, and it is. F of x is my y, so this says right now y equals 4x minus 7, and then I am switching my x and y, so my new equation is going to say x equals 4y, or y inverse, sometimes you'll go ahead and see, showing that it is the inverse equation, minus 7. Physically switch those two letters. Then you're just solving for this y inverse. So we're going to add the 7 over. So that becomes x plus 7. equals 4y inverse, and then you'll divide everything by 4. Depending on what you're doing with the equation, it might be reasonable to leave it x plus 7 all divided by 4. Just understand that it is all, not just the x and not just the 7. Or you could write it as y inverse equals x over 4 plus 7 over 4. Either equation is acceptable. What's going to happen if we compose a function with its inverse? We said this on the front. Your original domain, or your x, becomes the output. Or the functions cancel each other, leaving just the x value. And I'm saying x because it's whatever you put into it. Right? So that's where we're going to stop today. This last line's where we'll pick up on the next video. Thanks.